Hi, I'm Ruchir Reddy. I'm a student from Practical Aspect of Cryptography, and I'm gonna show you the implementation of our project. First, to describe about the project, it is an advanced hybrid cryptography application that combines the RSA and AES algorithms to provide the robust security for message management. We have a we have used these two algorithms to manage two large prime numbers to that which are selected and multiplied to create a modulus, and then public and private keys are generated from this modulus, and the public key encrypts the data that only a private key can decrypt. And why when it comes to why we use the RSA algorithm, it is a good algorithm, for secure key exchange without requiring a pre-shared secret key. And We also used AES algorithm that uses a single key for both encryption and decryption. Also processes the data in fixed size blocks of 128 bits. It applies multiple rounds for substitution and permutation. We used several dependencies such as C++ compiler, FLTK, also known as Fast Light Toolkit, OpenSSL, GMP, CMake, and these are used because C++ gives us the critical features for modern C++ development, including improved memory management, lambda expressions, and standard library enhancements. Coming to the FLTK, lightweight, it's lightweight and cross-platform GUI toolkit for minimal dependencies. Since we are using C++, which is a very older programming language for our project, it's suitable for us to use this toolkit to provide a GUI. Graphical user interface, of to demonstrate our project. And moving forward on how it is implemented, the AES 256 key is generated for each message, and RSA public key is used to encrypt this AES key, and plain text is encrypted using the AES key, and the encrypted message and RSA encrypted AES key are stored together, and encrypted messages are stored with the encrypted AES keys, where no plain text or keys are even stored unencrypted. Coming to the decryption process, the RSA private key decrypts the stored AES key, and this recovered AES key is kept in a memory only temporarily. And recovered AES key is used to decrypt the message, and once the decryption is complete, the AES key is securely wiped out from the memory. Coming to the security considerations, as I just mentioned, the keys are securely wiped from the memory after usage, and um, uh, constant time operations are used whenever and wherever possible, and cryptographic failures are handled without revealing sensitive information. Coming to the technical specifications of our project, uh, 2048 bits is used for the RSA key size, which is strong, which gives us the strong security with reasonable performance, considering the project. And the AES 256 CBC with the random initialization vectors gives us the AES configurations. And the key derivations are produced with the strong random number generator for AES keys. Moving forward with the demonstration, we are using the Replit online tool to use all these dependencies together, which is easy to import just by mentioning it in the code to use these dependencies. And now I'm going to show you the source code. This is the AES. This is the code where the AES keys are generated, where the encryption and decryption happens. And this is the header file for the AES, where everything is mentioned to call out all the CPP files. This is the main C++ file, and this is the RSA C++ file where the cipher block is used to generate the keys and encrypt and decrypt the messages. Now I am going to um, run the code for all of us to show, and there we go. So coming to the UI, since we are using the C++ and GMP for the for the GUI, it looks a pretty old one, like the Windows XP, but it pretty sure it works. And here we have three text fields where for two of which we can edit, and the third one shows us the message history. In the first one, we can enter the text to first generate the keys. Let's just say testing the project, and then click on generate keys. The algorithm is used to generate the keys. Since this key is highlighted, this a key is going to be used for encryption and decryption. Let's say for this is the practice demonstrate project. So let's just say this is the message that we want to encrypt. And we just need to click on encrypt, and we can see the encrypted message, and also the key that is used for the encryption. Of course, this is used, this shows the key name, not the actual key that is encrypted, that is used. This is just the key name, which we are giving as the user input while creating the keys, while generating the keys. With this, you can just copy the output, and you can just paste the output over here to decrypt it. It usually it's basically, instead of copying it manually, we had a functionality to copy the whole output and paste it in the first text box to decrypt the message, to decrypt the encrypted message. And once we click on decrypt, it decrypts and shows the original message, which is, in this case, this is a practical demonstration of the project. And the third text box shows us the message history. This was done on 23rd April at 1:39 a.m. I'm not sure why this is the timings that is being showed, but as of now, um, I'm in the EST. It's 9:41, somewhere around. So when we check on these details, when we click on these details, we can see the key name that is used, the original text, and also the encrypted text. And we can even go back from the message history, and if you want to delete this message, we can delete it from here as well. Yeah, and these we had several functionalities here. First, to generate the keys, use multiple keys, and we use the same text box to type in the message by clearing the key name, and we click on encrypt or decrypt to demonstrate the cryptographic system. And yeah, this is the project we have been working on for this semester. Thank you.